Hi, everybody. My name is Yi. I come from University of Wisconsin, and this is a joint work with Bowen and DK. DK is right over here, and Bowen is about 400 miles away from us. It's generative AI, open source, and what we call application layer product development. So let me get into the details. So the motivation of this work is something about open source LLMs today that we can see a lot. And of course, this kind of open source LLMs are influencing the procedure of product development. So basically what we are seeing is like there are two layers in this kind of product design thing. So the first layer is what we call foundation model, or the developer layer. So basically the providers of such foundation models like Llama, like OpenAI. So this kind of, sorry, OpenAI is not actually open. So this kind of real open models, these are the foundation model developers for everybody to use. And what we are going to focus on in this talk is actually what we call the application layer. That means what? That means we just try to use this kind of foundation model and try to build our own applications and try to, try to deliver some products to the end users. For example, just think about these language models, large language models, and we can use them to build an app. Build a generative AI-based, let's say, tutoring app. Okay, so basically you can ask them for your math problems, for your or even writing tutoring. And so what we are focusing on is this kind of application layer. So they will build the application incorporating the foundational model, and basically they will use some fine-tuning approaches to make this model more applicable to the specific application we are using. And the reason why we are going to do this work is we see there's some fundamental differences between traditional versus this kind of LLM or generative AI-based open source models. So in the traditional open source model, we usually see some certainty in this kind of shared improvement. Because of the modularization, usually things are packed in different modules. So if you want to add a new feature, you want to fix a bug, all these things are more like module-based. So the improvement, and also the improvements become accessible to all other developers. So that the collaboration is more easy to do because firms can work together with this kind of modules, and they can improve the foundation model, and they can also use them for their own job. So basically, firms will work together to improve the functionalities, just like this operating system, like Linux. However, for LLM-based open source, the things will be more complicated. And we try to identify two things that are really different in the sense of open source, in the sense of LLM-based open source compared to traditional ones. One we call that the uncertainty in improvement or fine-tuning, and the other one is what we call collaboration inhibition, which we'll explain in a second. So these two things are what we see the challenges in product development through open source LLMs. So the first thing is what we call fine-tuning uncertainty. That's a thing that's related to instability and the risks, which means so in traditional open source, when you try to improve one module of the open source model, usually the other modules are not affected. So basically, you can make improvement and without hurting other parts of the model. But for the open source LLM, for LLMs, we know that they are like a black box. And usually, when you try to use your own data to do some fine-tuning, when you improve the performance in one dimension, it may hurt the performance in other dimensions. And these things may happen in an uncertain manner. So it's like a random manner. So these things may happen, but you are not sure before you really do this. So that's something related to model drift. And another thing is about LLMs is like because of this kind of uncertainty and because there's a lack of standardized software and engineering practices for LLMs, usually it's hard for firms to collaborate on this kind of open source models compared to the traditional open source age. So these two things are the two important differences in terms of open sourcing in the age of LLM compared to the age before. So our research question is just like, how do fine-tuning, uncertainty, and collaboration inhibition, these two important characteristics that we identify for LLM-based open source, how will this affect application layer firms' competitive landscape? And so first thing is like how this will change the innovation level, LLM-based open source compared to the traditional age. How will this change the innovation level for the application layer developers? And another thing is like we want to see whether this will improve or decrease this firm's profit. Especially we want to see under what conditions can this kind of LLM-based open source models really can provide higher profit for these developers compared to the traditional age. So this is our model. We just built a two-stage game theoretical model with the first stage about product development effort. So that's the effort stage, and then it's like the pricing stage. The developers or these kind of application developers that will compete on price. So let me get into the details of the model. First of all, we have a competition between two firms. So these two developer layer firms, they try to develop some consumer-facing and user-facing products, and they will use this kind of open source LLM. And the firms will apply the model to their own application layer products. And there's some effort engaged here. So basically, with this LLM, that's the foundation model, they can do some vertical effort to improve it in terms of this absolute performance and try to bring the foundation model down to the application layer. So this is true for all the application layer firms. Or you can also do something that's more horizontal, that is try to differentiate yourself from your competitor. And this is especially as marketers, we know that this is very, very important. You want to add some of your own characteristic into this this product. So again, go back to our example of LLM-powered tutoring product. So if this tutoring app is what you try to produce, of course you can increase its let's say the language ability, and that will be common for all these tutoring products. Or you can do something that is more like differentiating yourself from others. For example, you are good at solving complex math problems, or you are really good at your teaching. Okay, so you have some specific advantages in your education skills. So whatever. So basically, you want to do something that is trying to differentiate yourself from others. So that's the horizontal effort. And effort, of course, is not costly. So this is we assume a quadratic cost for the development. And we just assume zero marginal cost, and the price is PI. Then we talk about the customer preferences. We have a hoteling line framework where each customer's utility is defined by a reservation value minus the distance for this customer and the product. And the V is the reservation value, and D represents the distance between customer X and the firm I's product, and the customers are uniformly distributed over a hoteling line. And the consumers, of course, will choose the firm that offers higher net utility after price. Okay? So this is just an illustration of the difference in the traditional open source model and the generative AI open source model. So in the traditional case, so first of all, there is kind of a collaboration. So basically, your effort in the common dimension or the vertical dimension can contribute to the others. Okay, so basically your effort here can somewhat contribute to the others, and here the effort here can be contributed to the others, So that's one thing. Another thing is like these two dimensions are just separate, just like two different modules. They will not affect each other. However, in the AI case, first of all, we just say like it's really hard for firms to collaborate, even on the vertical dimension. So we just set this W into 0. And another thing is that's more interesting is because we said there's kind of some model drift or there's kind of uncertainty in fine-tuning. When you try to fine-tune your model, your large language model, when you try to make it more differentiating from the others, that means like you spend some horizontal effort here, it will affect the performance in the vertical dimension, which means like there can be some alpha 1 times this E1 HAI. So that means like your effort here will make the other dimension's performance worse. Okay, and this alpha 1 we assume is a random variable that is uniformly distributed between 0 and 1. So this tries to capture this uncertainty. So don't know whether this really will hurt you before you make the effort. Okay, and same thing also happens to firm 2. So that's what we try to capture here. Okay, so that's the two things, two effort. And in the traditional case, there's a clear separation. But for the large language model case, the effort in one dimension may result in quality decrease in other dimensions. Okay. Now we have our result. So the first thing is about the development effort. We find that compared to traditional open source software development, in the case of large language model-based open source, each firm's vertical fine-tuning effort is higher. So this one is higher than that, but the horizontal effort is lower. This one is easy to understand because so nowadays the effort you spend on the horizontal will negatively impact your performance in the vertical dimension. So that's why you should shrink this a little bit not to affect the vertical too much. And also you have to spend more on the vertical axis to try to compensate this kind of decrease in quality due to the horizontal effort, due to this kind of fine-tuning uncertainty, okay? And by the way, this is a very important parameter, which is omega, that captures the distance between the foundation model to your application layer. That is how much, in terms of the absolute cost, you have to still increase to try to bring the foundation model to your application, okay? So that result is quite intuitive, and this is also related to the total cost. So you see in the AI case, the total cost is lower than in the traditional case only when the first collaboration in the traditional case is low. So that's also very intuitive because only when this thing is low, you can see the AI can really be more efficient, right? So the cost is lower. And also, you will see when the omega is somewhat moderately, in between. So sometimes it's like a moderately large. Sometimes it's just really large. So this is the reason is it's a joint effect from the vertical effort and horizontal effort. So as you see, the horizontal in terms of vertical effort is lower, it's higher, but in the horizontal effort is lower. So this is a combination of both effects. So you can see it's only the AI case is lower than the traditional case when omega is moderately large. The more interesting result happens in the profitability. So if you think about these two effects, okay, the first effect is what we call fine-tuning uncertainty. So basically you add some negative impact on the vertical dimension when you try to do fine-tuning, right? So it seems like it's a bad thing for firms. Another impact is the collaboration inhibition effect. It's also a bad thing for firms, right? So both effects are giving the firms a harder time compared to the traditional age, in the age of LLM-based open source. However, we do find in some cases, in the AI case, the profit of these developers can be higher. So why seems like two bad things can contribute to a higher profit for these firms? First, we want to claim that the collaboration inhibition effect always definitely will do a negative thing, right? Because you cannot really collaborate with others, so definitely the marginal benefit decreases. So this one definitely will decrease the firm's profitability. Then the increased profitability definitely has to come from this fine-tuning uncertainty effect. Why this can bring in some positivity for the firms in terms of their profit. We try to say this in a term called artificial vertical differentiation. Why? Because there's some uncertainty in terms of their vertical development, right? When they try to spend more on their horizontal and their vertical dimension can go down, the quality can go down. So because there's some uncertainty, it creates some artificial vertical differentiation between the firms. So in the age that everything was certain, so both firms, especially when they are symmetric, they will spend the same level of vertical effort, and that will create some head-to-head competition. And that will, so the firms can only make money from the horizontal differentiation, okay? But in the age of AI, because you can see, even if firms are symmetric, there's a term that is, of course, is uncertain, but that makes the two firms not symmetric. And not an asymmetric case can actually increase firms' prices in some cases. And that's why we say, like, even two effects, dividends two effects are both negative, seems negative. They can have some positive impact on firms' profitability. Okay, so I think I'm running out of time, so I'll skip the discussion on welfare. Just quickly conclude, I'm saying firms face both challenges and opportunities with open source LLMs. And LLMs provide unique vertical differentiation opportunities, this kind of what we call artificial differentiation in terms of their vertical dimension. And this may increase their profitability, even if these two effects both seem negative to firms. I'll stop here. Thank you. So the thing is just whether the development on one dimension will affect the quality on other dimensions. So this is very specific to large language model based or generative AI based open source, and we have seen this in many cases. For example, if you try to increase the helpfulness of some large language model, and the truthfulness of these models can decrease. We have seen this kind of examples, and that's the key idea of this paper, and that's the key thing that we try to say, that this may not be a bad thing for the firms to try to apply these foundation models.
So that trade-off can be determined by the companies that are applying.
Right. So we only focus on the application layer firms. Yeah, like this.
Maybe one last question. If not, then thank you so much.
Thank you.